In this video, we're going to go over the depreciation problem from the Section 1.2 activity. The problem says, a charter fishing company buys a new boat for $224,000 and assumes that it will have a trade-in value of $115,200 after 16 years. The company uses a constant rate of depreciation, which is commonly called straight-line depreciation and is one of several methods permitted by the IRS, to determine the value of the boat. So the first question says, what does depreciation mean? So what we're going to do again is we don't want to just Google a definition. We want to think about understanding what it really means. And depreciation means that some items, especially things that are machinery or vehicles, anything like that, is going to lose value over time. And that happens because they get worn out. So as they get worn out, as time goes on, as they're being used, things break, they break down, and so they lose value. Not everything in life depreciates. Some things like real estate will appreciate, which means that they gain value over time. But things that are mechanical will generally lose value over time. So the next question says, how much value does the boat lose per year? So we know that they're buying the boat new for $224,000, and we also know the value after 16 years. So if we're starting at $224,000 and we're going down to $115,200, we can figure out the total amount lost over the course of 16 years. And if I subtract those two numbers, I get 108,800, and that's being lost over 16 years. So I can divide 108,800 divided by 16, and that gives me a value of $6,800 lost per year. Question 3 says, what is the depreciated value of the boat after 10 years? Well, we know that it's starting with a value of $224,000, and we know that it's losing $6,800 in value per year. So multiply 6,800 by 10 years to get the amount lost after 10 years, and when I subtract those, I get $156,000. And that should make sense because it's less than my new purchase price, so the value should be decreasing. But it also is a little bit higher than the amount, the trade-in value after 16 years. So after 10 years, it hasn't lost quite as much as it will lose in 16 years. Question 4 says to find a linear model or equation for the depreciated value V of the boat T years after it was purchased. So this is just giving a general formula for what I calculated in question 3. To find the depreciated value, I take my starting value of $224,000 and I subtract $6,800 times the number of years, or T. So multiply the 6,800 by the number of years and subtract that from your starting value. That's my linear model or equation. Now I can use that to answer question 5. When will the depreciated value fall below $100,000? So V is my depreciated value, or my current value, value after time. So to find out when that will fall below 100,000, I plug in 100,000 for V, and then I'm solving the equation for T. There's other ways that you could do this problem. You could set up a table, you could do some guess and check, lots of ways that you could do it, but if I want to use an equation, or use my equation that I found in step 4, this is how I would go about it. So now I'm solving this equation for T. So subtract 224,000 from both sides. And that's going to give me negative 124,000 equals negative 6,800t. Divide both sides by negative 6,800. The negatives will cancel out, which is good, because I don't want t to be negative. And I will get t, it's going to be an approximation here, 18.23. Now, when you're doing this on the homework, you'll see the instruction there is to round up any value. So what this means is at about 18.23 years, so about a quarter of the way into the 19th year, that's when it falls below $100,000. The way that I would enter this is that it's during the 19th year. So whatever decimal number, that's an A, whatever decimal number you have here, you would just go to the next highest whole number, so the 19th year. Lastly, we're going to graph on Desmos. So I'm going to bring up my graph again. I have my old graph on here. If I want to get rid of this graph, I can do that by just clicking on the 3 lines and clicking New Blank Graph. And then I will get a new blank graph. So the equation that I'm graphing here is y equals 224,000 minus 6,800x. So there's my graph. Again, I can't see it because I need to change the scale. This time, instead of doing the zoom, I'll just go ahead and change my axes here. I know that I want to go from 0 to 30 on the x-axis, or the t-axis. And then on the y-axis, I can start at 0. Let's go up to 250,000. Okay, and there I see my graph. With my y-intercept of 224,000, I see a negative slope in this graph, which makes sense because my value is decreasing as time goes on. So again, I'm going to click Share Graph, export the image, download PNG, and then I can go back to my notes and insert picture from file. There it is in my downloads, and there's my picture.